4, 3.
This is a video for Math 141 Finals Review. Given 2 points, I'm going to ask you to create a quadratic function. Before we can do that, we need to have the points identified for us. We're going to use this point here as our vertex. So this is our h value, and this is our k value for our vertex. And this is just another point that happens to be on the graph. So we're going to start with vertex form for the equation. Vertex form of a quadratic is y equals a times x minus h squared plus k. So the first thing we need to do is we need to solve for a, and we need to solve for k. Oh, sorry, we need to solve for a. We have h and k. We're going to use this right here. So we have y equals a times x. Our h is already negative. When you subtract a negative, it becomes a positive 2. And our k is positive, so we're going to just leave it as positive. So now I need to solve for a using my x and y value from the other point that is not the vertex. I'm going to plug that into this equation here. My y value is a 2, and my x value is a 3. Combining these, I get 5 squared. That gives me a 25. 2 equals 25 times my a plus 3. I'm going to subtract 3 from both sides and divide by 25. Now that I have my a, I have my formula for my function. So I'm going to call this g of x equals negative 1 over 25 times x plus 2 squared plus 3. This negative tells us that this is an upside down parabola. I'm going to put in my points on the graph. So I'm going to negative 2, positive 3. There's my vertex. I know this is a parabola that's facing downward because of the negative coefficient. The second point is 3, 2, 3, 2. And because this is a vertex, I know there is a reflection point directly on the other side of my vertex line. So this is 3 units and 2 units. So again, 2 units and 3 units. So it's approximately here. And I can do a quick sketch of this parabola. Now, because the parabola is not a one-to-one function, we can't find the inverse function for the entire function. We have to split this up into 2 separate functions. So I'm going to call the right-hand leg my g of x, and I'm going to restrict the domain so I can create the inverse function for this g of x. So I'm only going to use the x's that go from the vertex, which is at negative 2, and I'm going to make that inclusive. So I'm going to make this a square bracket at negative 2. And it goes to positive infinity. So by restricting the domain to the right of the parabola, that means that when I find my square root function, which is the inverse function, it's going to be the positive square root. I'm going to take you through that process now. Now we're going to look at how to change this function into its inverse function. In order to do that, we want to switch the x and the y values. So the variables get switched, and we're going to solve for our y. So instead of g of x, which would normally be y, I'm going to change that into an x equals negative 1 over 25 times this x now becomes a y plus 2 squared plus 3. I want to peel everything away from the y, get it over to the other side. The first thing I'm going to get rid of is the positive 3, so I'm going to subtract 3 from both sides. And the next thing I want to get rid of is the negative 1 over 25. And in order to get rid of negative 1 over 25, I want to multiply both sides by a negative 25. That will make this positive on the right-hand side, and we'll remove the 25 in the denominator. So negative 25 times x minus 3 equals y plus 2 squared. Before I take the square root, I'd like to simplify this a little bit. I can't take the square root of a negative 25, but I can take the square root of 25. But I need to get rid of this negative sign, so I'm going to distribute the negative sign into the parentheses. So that allows me to change this into 25 times 3 minus x. The x is now negative, the 3 is now positive, and the 25 is now positive. And now when I take the square root of both sides, I can easily deal with the 25 that's sitting out as the coefficient. Now, one of the things about the inverse function is we can't take the inverse function of the entire parabola. We can only take it of parts of it because it's not a one-to-one function. So I'm working with the right leg of the parabola. That means that we will go with the positive square root. If we were working with the left side of the parabola, we would use the negative square root. Taking the square root of 25 gives me a 5. And then I have to take the square root of 3 minus x, and that equals y plus 2. I'm going to bring this up here so it's easier to see. And now I want to subtract 2 from both sides, so I'm going to minus 2 plus 5 square root 3 minus x, and that equals my y. It's conventional to put the term that does not have a square root in it to the left of the term that does. That's just convention. It's okay to write it in the other direction, but make sure that you're very sure about indicating where the end of your square root is so that it doesn't look like the minus 2 is under the square root sign. So this is my g to the negative 1 of x. This is my inverse function. But when you're given an inverse function, you really should also indicate the domain for that function. And in order to do that, a square root cannot have a negative underneath it. So we're going to take the term underneath the square root sign. Sorry, that's a positive 3. And we want to make it greater than 0. It's okay to equal 0. Square root of 0 is 0. But we want this to be positive, so that's why it's greater. I'm going to add x to both sides. And that tells me that my x has to be smaller than 3. So I have x is an element of negative infinity up to and inclusive of 3. Now let's take a look at our graph. Our graph, we're going to switch the x and the y values to create our points. We have 3, negative 2. 3, negative 2. That was our vertex. And now we've changed it into 3, negative 2. Right here. And this 3, 2 is now 2, 3. 2, 3. And so our graph starts at this point. Remember, we can include 3, but we cannot be greater than 3. So we're going to include 3. We're going to come up, go through this point, and go in that direction. So we are only using from to the right, and you can see how these are reflective of one another.